All right, we got inverse sine, and it's 1, and I'm thinking of that as 1 over 1 for my ratio that I'm going to put into my reference triangle. I notice that this is positive, and it's inverse sine. Inverse sine means we've got to be in one of these two quadrants, and if it's positive, then it's in this one. So I go to draw my reference triangle, but I got trouble because how are you going to have a reference triangle that has an opposite and a hypotenuse that are both equal to 1? That's not a triangle. That's not possible. So what I need to think of instead is, so when we run into that situation, that should be a clue that we're talking about a quadrantal angle, one of either the x-axis or the y-axis. So then I'm going to think kind of a different way. Without a reference triangle, I'm thinking about when is sine equal to 1? At what angle around my unit circle is sine equal to 1? So my thought bubble is, where is sine x equal to 1? Well, sine is the y coordinate around our unit circle. Where does the y coordinate equal 1? What angle does that happen at? That happens at a 90-degree angle. That's the only place on the unit circle where the y coordinate is equal to 1. By the way, the x coordinate is 0, which means the cosine is 0 at that point. But the sine is equal to 1 at that point. And so we're looking for the angle where that happens, and that's this angle right here. And we're going to give it in radians. So pi over 2 is our answer. And just remind me, is pi over 2 a legal answer for inverse sine? Inverse sine can give us answers between negative pi over 2 and positive pi over 2 inclusive. So because of the square brackets, this is okay. So 12 would be pi over 2. So you've got a few of these where they end up on quadrantals. Number 4 was another one. 11 was, yeah, 11 was. There's 3 was another one. 3 was where tangent was equal to 0. Although with that one, you could think about opposite over adjacent being 0 over 1, which would be a 0-degree angle. Anyways, are we okay on those ones? So if you're working on one of these and you go to draw your reference triangle and it just doesn't make sense, then that means you're a quadrantal, and you got to think about this whole cosine comma sine for our x and y coordinates around the unit circle. All right, the other one I'm going to go over is number 14. Folks, I made solutions and I posted them on Canvas for this assignment. I think I may have skipped the ones where you just put it into the calculator, but you're all capable of pushing buttons. We'll do number 14 from page 432. All right, so here's what I'm going to tell you first. We'll preface this. On our test Friday, there is going to be one word problem involving right triangles, one only, and it's like a geometry level word problem. Okay, it's like a simple, it's like one of those, the ladders leaning up against the house, and like, I don't know, like how far up is the ladder going, or how far is the base of the ladder from the house, or what's the angle the ladder makes with the ground. It's one of those super basic ones, okay? That is not what I gave you in 14 through 17. These ones are significantly more challenging, but you will not see problems like this on the test Friday. However, those of you who are doing CWU, you should pay attention to this. 14, 15, and 16, there have been problems on the CWU 154 final the last 3 years since I've been teaching this class. There have been problems on the CWU final very similar to these. So you're going to want to pay attention to this. And the thing is, they are all very similar. Once you've solved one of these, and that's why I'm only going over number 14. I want you to see this, and then I want you to go back and try and do 15 and 16, because it's the same process, okay? And then the good news is that once we get through non-right triangles, next unit, these problems become even easier. So I'm going to draw the situation. Otis Evans is out hiking on a flat trail. So here's the trail. And way off in the distance, he spies Long's Peak. And he takes a measurement. Angle of elevation is always measured from the horizontal, so it's a good thing that it's a horizontal trail. The first time he measures it at 30 degrees. And the second time, he's a little bit closer. He's further down the trail here. And he measures it again, and it's 35 degrees. And that distance that he moved between those two measurements, that's your 1,000 feet. So the trickiest part of this for some people could have been just drawing the picture. And they want us to know how tall this thing is. I'm going to call it h for now. That's what we're solving for. And there's another important distance here. By the way, this is going to be a right triangle, a couple right triangles. I'm going to call this distance here x. Can you please stop? Thanks. And the reason I'm giving that a name is because I've done a lot of problems like this, and I just know I'm going to need to deal with that. I'm going to end up being able to solve for x. I won't ever actually, I'm sorry, I'll solve for h. I won't actually solve for x, but it's going to be important in kind of getting stuff set up. So are we okay with the setup to this thing? So really there's two triangles going on. There's one that's a 30, 60, 90 triangle with h here, and the base here would be 1,000 plus x. And then there's another one with h and a 35-degree angle, and it just has a base of x, and they're both right triangles. So again, because I have done quite a few of these problems, I know my strategy is going to be to write an equation for both of these triangles. That'll be my first step. Then I'm going to try and manipulate those equations to get x by itself, and then I'll be able to substitute one equation into the other, and that'll allow me to solve for h. So let's write an equation for this triangle. So I'm thinking tangent is going to be our trig function of choice. The hypotenuse doesn't come into play at all. It's all adjacent and opposite. So this is going back to just basic SOHCAHTOA from geometry class. Tangent of your angle is opposite over adjacent. That'd be h over 1,000 plus x. We'll come back and play with that in a moment. Let's go ahead and rewrite this as, or let's write an equation for this tangent. This time it's 35, and it's just h over x. That should be, like, if you can do that, if you can write an equation like this and then solve for any of these three positions, if you've got numbers for the rest of them, then you'll be fine on the test. Like if I had told you that x was 2,600 and you could solve for h, then you'll be good. Or if I told you that x and h were values and you had to solve for the 35, then you should be fine. All right, I'm going to do some manipulation here. I'm going to clear my fractions. Actually, I'm not going to clear my fractions. I'm going to swap. This is a little algebra shortcut. You guys remember from geometry there was a shortcut where you could swap those two parts? Yeah, so I'm going to do that. And then I could do this in two steps algebraically. I would just multiply on both sides by 1,000 plus x and then divide both sides by tangent 30. So I'm doing one step and two. So now I've got 1,000 plus x equals h over tangent 30. I'm going to do two more things to that. 1,000 plus x. I will get rid of the 1,000 in a moment, but I'm going to rewrite this as h times the cotangent of 30. That way I don't have a fraction. Are we okay with the fact that dividing by tangent is the same as multiplying by cotangent because they are reciprocals of one another? Then I'll get rid of the 1,000. So x equals h cotangent 30 minus 1,000. This is trying to be an h. We'll do the same thing over here just to get x by itself. This one will actually go much faster. These two things swap, so we get x equals h over tangent 35, and then we'll call that h times cotangent 35. So then we can put those two equations together now because they're both x equals equations. So we call this has a new name in our new textbook in Algebra 1. They call this equal values method. But the idea is it's true that x equals x. If that's true, then this thing must equal this thing. So let me write this equation. H cotangent 30 minus 100 equals h cotangent 35. It's 1,000. Thank you. Lost a 0. Bless you. And then from here, we'll just we'll just get h by itself. We got h's on both sides. We've done a lot of these problems this year where you've got h's in multiple, or the whatever variable in multiple places. Your strategy that I'm hoping you're thinking is, let's get all of our h's on one side and factor out an h, and then we can divide and get h by itself. So I'm going to choose to get my h's over here. So here's my next step. H cotangent 30, bringing this over, so now it's negative h cotangent 35. Adding 1,000 to both sides. We'll get that 1,000 off of that side. And now it's not negative anymore either. And I'll factor out an h and divide on both sides, and we'll be there. Cotangent 30 minus cotangent 35. Man, this thing is just not. And then that just goes into my calculator. I don't have a cotangent button, so I'm going to have to use 1 over tangent for each of those.
Can I take a picture of this?
No. It's on Canvas. And we are dealing in degrees here, so I want to make sure my calculator is in degree mode, which it is. So 1,000 over, begin my denominator, cotangent 30, I'm going to type 1 over tangent 30, minus cotangent 35, I'll type 1 over tangent 35, and my denominator, hit enter, and there we go. So it's a little bit of a messy solution. But that's all right. We got it. We ended up getting there in the long run. All right, so now that you've seen that, I encourage you to follow the same process for problems 15 and 16. You don't need to go back and redo this one, but I would like you to, if you don't have a good solution for 15 and 16, follow that same process. In each of them, you're going to end up with two triangles. One's going to be like some number plus a variable. The other one will be just that variable. And the process is always going to be the same. Write a simple SOHCAHTOA equation for your two triangles, and then get that variable by itself, and you'll be able to stick those two equations together and solve. They don't always turn into cotangents. Some of them will be tangents. But yeah, they follow the same process. All right. Okay, the rest of your questions, I'm going to direct you to the solutions that are on Canvas. So let me stop my recording and I can show you where those are. Or maybe not. There we go.